Hi everyone, it's Tom Stevenson, and today we will review the multi-state display module that is a part of the Virtual Ion Processor, or VIP, in the Power Monitoring Expert 8 release. And this module essentially allows you to enable representation of changes of state. If you're familiar with the status object in Vista today, you'll know that it has two states, whether on, off, enabled, disabled, open, closed, and in some applications, the need for more states are there if you wanted to represent open, closed, and racked out, for example. And this could be accomplished with the current product with a technique of layering multiple status objects on top of each other, which is quite time consuming and difficult to maintain. So this module aims to take some of that complexity out of the mix, and it's coupled with some Vista support for multiple states. So just to get started, let's just review some fundamentals of the module. For inputs, there are four bits A, B, C, and D. And these can be linked, of course, to, in this example, we'll just use external Booleans. In practice, these could be linked to breaker open-closed registers, breaker racked out registers, various I/O from different devices, or logic within the VIP itself, which could span multiple devices. And essentially by linking 4 bits, we essentially build a binary number. Now, before we go further, let's talk about a couple of other fundamentals. If you've watched the Power of Ion video from about a year ago, we talked about the concept of enumerated registers. And I'll show you just behind the scenes what an enumerated register is in the Ion world as just a means of further understanding what this module is doing. Right now, I'm using a test program called Ion Test to directly interrogate a 7650. And I just happen to know that the handle for volts mode is 7800 in hexadecimal. And by operating on it with a register read value, which is just asking the meter what's this programmed to, and the third argument doesn't need to be specified, we can see this meter is in 4-wire Y. Now in Ion Setup or in Designer, when you're presented with a list of possible options for the volts mode on a meter, the way the software knows what the device supports is using this method, which is enumerated register read enumerations. And this is where the device tells us every possible enumeration that the device can be programmed to. So the 7650 can be programmed to 4-wire Y mode, to delta, to 3-wire Y, single, or demo. So Designer can then let you select from this list and write it back. Now, the reason I'm covering this topic just really quickly is essentially this module here is an enumerations builder. So if we look at the output registers, the primary one you will use is this multi-state display output register, which is an enumerated register. And this is because in Vista, everything is constructed around the object, so we need to link everything to a register that can be linked to, in this case, the multi-state display register. Now, in this other window with Ion Test, this handle here, 2A00111, is the handle of the multi-state display output register. And you can see in this case, it's returning the 0000. Now, if I ask this register what possible values it can take, you can see it returns me 16. And these 16 are the bit combinations of bits D, C, B, A. So if you recall, that's what we linked our input registers to. DCBA, and all the possible values are 0A, 0, 0, 0, 0A, 0, 0, 0, 0, 0, B0, etc., etc. So what this allows us to do now, when we look in Vista, you will see that Vista now lets us associate a color, an animation, or a picture with each of these distinct states. So this is what's happening behind the scenes in the module. Now let me just show you quickly where all these labels are coming from. And that most simply is these setup registers. And by default, you can see each setup register has the labels we just saw in the ion test window right here. But let's make this real. Let's say that in this case, where all the bits are not asserted, we want the state to be breaker off. In the case where the first bit is on, it's breaker on. And in these two cases where bit B is asserted, independent of bit A, we may want to say racked out. Racked out. So I hope this makes sense. If we see bit 2 asserted, which we'll assume just means the breaker is racked out, anytime that that's asserted, independently of whatever the first bit is, the state is racked out. Now, if I set and save that, and we go back to our ion test window, if I execute the same command, what possible values can I get? Breaker off, breaker on, racked out, racked out. So those are all the possible states this module can provide. Now in this example I have shown, I've linked 4 inputs, but I really only need the first 2. And so you don't need all 4 of them linked necessarily. In this case, it's a two-state example. And you can see now, once I've eliminated the other 2 inputs, that there's actually only 4 states I can achieve. Breaker off, breaker on, racked out, and racked out. If I move now to Vista, let's see it in practice, because I've really just shown you the behind the scenes part. I've now, just for convenience, linked D, C, B, A as switches. And if I link a status object now to the multi-state display register, there it is, and we move to the display tab, we can now see, we'll put it in alphanumeric to begin with, and you can see now Vista has used that read enumerations method to see that there are 4 possible states that can be returned. And this now allows me to change the color of each of these states. And in this case, we may, want to have a more similar color if it's racked out, because from a user-facing perspective, we don't distinguish. So if I let that update, you can see I'm getting the blue color, and I've just chosen alphanumeric display, so I'm getting the breaker off label directly from the module now. As I mentioned before too, if I just use default images, okay, and if we now toggle one of those bits, we will see the status object will update with an appropriate color that is, in this case, the defaults. And this is all done with a single status object now. And as I mentioned earlier, there's the custom images aspects of Vista now too, which existed before, but now it supports some various animations that weren't supported previously and can be used with this object as well. I like the alphanumeric mode for demonstration purposes, just because we can see what the value is. So in this case, breaker on. In this case, we should see racked out. And as I mentioned, if that second bit is asserted, It'll still say racked out here. We might get a slightly, we program the same color so it just appears transparently to the end user. And how can we see this in Designer? If we look at the output values, we're seeing racked out is the value. And for convenience, if you wanted to signal an alarm or a notification or an email in a very specific state, for convenience, there is an output Boolean register for each of the possible states that can be linked to a set point module, either for the creation of an alarm or for the sending of an email or other logic. So what this is telling us is that the bit B is asserted, which makes sense. If we also look at our inputs, we can see bit B is asserted, bit A is not. And that's really all you need to know about this module. We've talked about enumerated registers, which is the multi-state display register. We've talked about how these setup registers essentially build the enumerations associated with this multi-state display register, and how we can change the labels here to build a new set of enumerations for this display module and then show them in Vista, or use these status outputs to trigger an alarm. Some of the applications we could then look to, and Dana Davidson is looking at a potential TBD, but he's done it in the demo, for this energy usage intensity map in the Power Monitoring Expert demo, which shows using that same status object in Vista and the multi-state display object in the VIP to do the KPI calculation, and then showing an appropriate color for a given room in a building. So that's one potential application. Other applications include high, low alarm type applications, and the combination of registers from multiple devices or calculations within the VIP to produce some meaningful labels in your Vista diagram. Okay, I hope you have fun with the multi-state display module, and if there's any questions, as always, please let us know, and we look forward to hearing all about it. Thanks very much.